David Smith here with one more flipped classroom math lesson. 3 tips. First, you can adjust the playback speed faster or slower as you desire. Second, you can pause the video at any point to catch up with your notes or jot down some questions. Third, you can turn on the captions and read my words on the screen. Today's topic covers sums of convergent geometric series. So let's take a look at that picture before we get into how to calculate these. So here's our general formula for the sum of a convergent geometric series with n terms, sum of n terms, and there's our formula. We worked with that in our last lesson. So the thing about a convergent series is your r value has to be bigger than -1 but less than 1. That's what causes the series to converge. Now let's take a look at one of those. Here's a series that starts with 200, goes to 100, goes to 50, goes to 25. So what we're doing here is we're multiplying by 1/2 each time. So that each successive term is getting smaller and smaller and smaller. Now you can imagine that as we get out to the 100th term or the 1000th term, we're adding just a very little bit more to the sum. So that's why this series converges on a number. And that number is the number which the series is never going to be bigger than. The sum is never bigger than that number it converges to. So in this lesson, we're going to calculate what that sum is, what the convergent point is. All right, so here is a formula for the sum of a convergent series. Notice how I wrote the infinity symbol here. So this means the sum of the series as it goes out to infinity. We get infinity terms. So the sum, it's very simple. It's just u1 divided by 1 minus r. And that will give you the sum of your convergent series as you run the number of terms out to infinity. Notice how we're making sure that we're dealing with a convergent series, so r has to be bigger than -1 or less than 1. Another way to state this is the absolute value of r has to be less than 1. This is a little more mathematically concise. Okay, let's do an example. So we're looking for the infinite sum of this convergent series as we go from 200, 150, 25, all the way to the infinity term, okay? So go ahead and use that formula, do your plug-in for this series, and come back with your sum. This is a pretty straightforward calculation. I have my u1 over 1 minus r, so I have 200 over 1 minus 1/2, which is 200 over 1/2, which gets me 400. Now this kind of makes sense in an intuitive level, because if we keep adding terms, we're getting closer and closer to 400. Because watch, 200 plus 100, now we have 300, now we have 350, now we have 375, and so on. So as we keep adding terms all the way out to infinity, we're going to get closer and closer and closer to 400. So the way we state this is the sum of this infinite series converges on 400. All right, given what you've seen so far, I think you're equipped. What I'd like you to do is calculate the sum of this convergent series using your formula, steps we did before. Pause the video and see what you get. All right, let's see how you did. My r is 1/3. That's what I'm doing to get the next term each time. 1/3 times 1/3 is 1/9 times 1/3 is 1/27, and so on. So there's my r value. My first term is 1/3. Straightforward plug-in, u1, 1/3, minus 1 minus r, which is 1/3. So I have 1/3 over 2/3. When I have a fraction divided by a fraction, I flip and multiply, and that gets me 1/2. So this series, the sum of it, converges on 1/2. All right, here's another one to try. We looked at this sequence in a previous lesson. So what I'd like you to do is find the sum of this as an infinite series. All right, so check this out. I first had to figure out my r just to make sure this is indeed a convergent geometric series. And of course, what we're doing is we're multiplying each term by 1/2 to get the next term by -1/2. So our r is -1/2. That falls in the range, so this is a convergent series. Here is our first term, 1/4. So I just did my straightforward plug-in step into my formula here with first term of 1/4 over 1 minus r, which is also negative. So this ends up being 1/4 over 3/2, flip and multiply, and the sum of this convergent geometric series is 1/6. All right, let's try one more. Now I've given it to you in sigma notation, so go ahead and pause the video. You can get everything you need from here and go ahead and find the sum of this convergent geometric series. Let's see how you did. So first off, I need to check for my r, because if I don't have my r in the right range, this is actually not a convergent series. However, I'm good to go. I know that's r, so my r is minus 1/3. Now the other piece I need for this series is I need to know what my u1 is. And it's not given. I have the formula, so firstly I can calculate it really quickly. I just plug in 1 for n, do my math here, and I get 2/3 for my first term for this series. So now all I need to do is plug in what I know into my formula, and I can get my sum. So here's my u1 divided by 1 minus my r, which is negative 1/3. Working that through, I get 1/2 as my sum for this series. Here is a word problem that relates to this topic perfectly. So what we've got is we're dropping a ball from a height of 1.5 meters. Now each bounce, it comes back up 75% of the height that it was dropped from. So we have this ball that's bouncing and coming up lower and lower and lower. The question is, what is the total distance it travels before it comes to rest? So each time it goes down and up and down and up and down and up, it's traveling a distance in time. So we want to know the total distance traveled by the ball. Now, pause the video, see if you can extract from here what you need to sum this geometric series. Obviously it's convergent, so see if you can do that. All right, let's see how you did. Our u1 is 1.5. That's the height that we drop it from to start. Our r is 75% because that's the next term. It comes up 0.75 times. So that's the number we have to use to do our math. So now I'm going to set up my sum. The sum of this infinite series is 1.5 over 1 minus 0.75, which gets us that all the way to 6. Now think for a minute. Are we done? If you said no, you're correct, because this ball is not only traveling down. We just got the downward paths of this situation. So there's a little bit more to do because it's also traveling back up after each time it hits. So pause the video, do the critical thinking steps necessary, and see if you can come up with the total distance traveled. Okay, so you realize that it's coming back up each time. So our sum is going to be twice the 6. If the 6 is the down ones, we're actually coming back up as well. So we're going to do 2 times 6 for 12 for our total distance traveled. Now, think about that one, because we're not done. There's one more thing we have to do to get the total distance traveled by the ball. So here's the deal. It only travels the 1.5 from the first drop one time, not twice. When we multiplied the 6 by 2, that included that first drop 2 times. So I have to subtract 1.5 from my 12 to get 10.5 meters for the total distance traveled by the ball. Now that you've watched the video, take a moment to jot down some notes, some questions, or a quick summary of the content. You can also re-watch the portions of the video that were a little bit challenging. If you enjoyed the video, please click like, and if you'd like to help me grow my YouTube channel, please click subscribe.